Students often say to me in the comments, can you make one video that sums up every single trick you need to know for the GRE and GMAT? And fair warning, this video will not be that. Why? Because it's not possible. There's no way you can sum up everything you need to know for the quant sections of the GRE and GMAT in one video. Furthermore, having such a video misses the point, because the point about getting better at GRE, GMAT, Quant is to learn the methods, not just the formulas, and to practice them repeatedly. It's not about memorizing a list of formulas, it's about practicing methods repeatedly. So you might be thinking, well, why am I doing this video? What's this video about? Well, I saw this list from Prep Scholar about the 38 GRE math formulas you must know. And I thought what might be interesting for you is if I give my opinion about how important each formula is for you to know and how often it might come up. Obviously, I'm not going to go into too much depth in each formula because that's for all my other videos, and do check out my Quant playlist. But I'm just going to try and give you my opinion about how important it is you need to know this formula, how few students do or do not know the formula, and just some helpful bits of advice, hopefully, about how you might use those formulas. I guess some students might use this video to quickly brush up or remind themselves in the minutes before the test. But for those students, I'd say honestly, just chill out and do your best. Okay, without further ado, let's look through this list of the 38 GRE math formulas that Prep Scholar says that we must know. And it starts off with a square and says that the perimeter is 4 side lengths. If S is a side length, the perimeter is all the way around the edge, and that's 4 side lengths. I would say the vast majority of students would know that, but some students do forget. Mainly they forget that perimeter means all the way around the outside. I think it's to do with the etymology of peri being the outside, meter being measure, perimeter measures all the way around the outside, the length. So they're starting off with a nice easy formula here that I think most people will know, but some people forget the definition. And for the area, you multiply any two sides together. I think everyone kind of knows that for a square. A rectangle, you do the length times the width. I think pretty much every student I've met knows that. And the perimeter, yeah, there's a formula for that, but it's again kind of obvious. You do the length plus the length plus the width plus the width. Again, it's to do with remembering that that word perimeter means measuring around the outside. That's what some people do forget. My advice, writing it like a formula like this doesn't really help too much, so I wouldn't worry about that. And the area, length times width, as we've covered. This is more like it. Circles. People do genuinely forget this quite a lot. People do forget that the area of a circle is pi r squared, where r is the radius. Some of the mistakes they make is they square both of them. No, it's just the radius being squared. Other students get mixed up between the diameter, which is all the way across from one point on the circumference to the opposite side, and the radius, which is from the center to the circumference. But most people do know that formula pi r squared. Less commonly known is the circumference, which is 2 pi r, also remembered as pi times diameter, same thing. But again, I think this is more a case of people knowing the formulas and sometimes forgetting them, rather than never being familiar with them. And they're just explaining here that pi can be rounded to 3.14. Good to know. Okay, and again, they're talking about how the angles in a circle are 360 degrees. That's commonly known. Pythagoras. The thing with Pythagoras is that people do know it in the back of their heads, that you have the two short sides, and if you square them and then add those two squares up, you get the square of the other side. But it is quite commonly forgotten. Often if someone hasn't done math since high school or secondary school, we'd say in Britain, then they tend to forget this formula. If you remind them, they go, oh yeah, that formula, that formula. What's the most common mistake? Is not to remember that C has to be the hypotenuse. The long side, C, the one opposite the 90 degrees, is always going to be the hypotenuse. That's always going to be your C. The A and B are the two sides next to the right angle, and you can't flip that around. C can't be A or B. Another common mistake I see quite a lot is people forgetting to square root at the end. So say you've worked out A squared, and then you've worked out B squared, and then you add them up. They just say, boom, there's our answer, some big number. But actually that big number equals C squared, and you have to square root to find out what c, the hypotenuse, actually is. But still, we're dealing with a formula that I would say more than 50% of students would know, but it's good to know for anyone. The famous area of a triangle formula. The area of a triangle is a half base times height. The one thing some students might be surprised to see in this diagram is that the base can be this long side, can be the longest side of the triangle, as long as the height is the perpendicular height. The height is not one of the slanted lengths. The height must be perpendicular at right angles to the base. So we can do base times height divided by 2 for this triangle. It doesn't have to be a typical triangle like this where you do base times height divided by 2. We could make c the base, as they've done here, and then make the height the perpendicular length. But either way, we're doing base times height divided by 2 to get the area. Pythagorean triples, which some of you might have noticed up here, I might cover in a separate video, but they're just sets of numbers that you can memorize if you want, where the first one squared plus the second one squared equals the third one squared. Sometimes useful for remembering for Pythagoras, but really the only two that I actually memorize are these two. Not a huge deal, doesn't come up that often, particularly for the GRE. I may cover them in a separate video though. Obviously with the calculator, you can just work them out on a calculator if need be. Okay, and we've covered the area of a triangle. Trapezoid, sometimes called a trapezium. This is a fun one. Most people don't know this formula. I wouldn't say it's absolutely essential because you can work out the area of a trapezium just by breaking it into rectangles and triangles, but it is a fun shortcut. There's actually a song for it. Half the sum of the parallel sides times the width between them. That's how you find the area of a trapezium. But that song, as a formula, is half times the sum of the parallel sides, a plus b, they're the two parallel sides, times the width between them, the height, the distance from the two parallel sides between each other. So to cut a long story short, for a trapezoid or trapezium, you add the two parallel sides, then you divide that by 2, and then you times it by the height. And in one go, that gives you the entire area of the trapezium. It's a fun shortcut, not absolutely essential, doesn't come up that often, but there you go, good to know if you want to have a shortcut. Exponents. What can I say about exponents? Absolutely essential that you know, will definitely come up, and most students forget one of these rules at least. I've done multiple videos on exponents, so I'd strongly encourage you to check them out for a much more detailed discussion of exponents. This video is not going to cover all of exponents, of course, or any of these formulas. It's just to give you an idea of what's important and an overview of this formula sheet. So the first thing they start off with is that anything to the power of 0 is 1. Not many people know that. 100 to the power of 0 is 1. 1 to the power of 0 is 1. X to the power of 0 is 1. Anything to the power of 0 is 1. Another thing people commonly forget, a negative exponent, as in x to the power of negative 1, doesn't mean minus x or negative x. It's nothing to do with a negative. It's to do with 1 over. In other words, the reciprocal of x. Or, for example, x to the power of minus 2 doesn't mean negative x or minus x. It means the reciprocal of x, so that's 1 over x squared. So the only effect of that negative in the exponent is to reciprocate the original term. Again, this is way too much to cover in one video, but just to give you an inkling of the kind of mistakes that people make. And yes, all of this comes up a lot. People do forget that when you multiply exponents with the same base, you add the little powers. People forget that all the time. People sometimes forget, although less commonly, that when you're dividing exponents with the same base, you take away the powers. Many people don't realize that when you multiply exponents with the same power but different bases, you can just join the two bases together. Again, I'm not expecting you to memorize all of this. I'm doing it way too quickly. I'm just pointing you in the direction of some of the topics you might want to spend more revision time on. A lot of people don't realize that when you have a fraction to a certain power, then the power applies both to the numerator and the denominator. And finally, this comes up a lot in the test. Half of people know, I would say, is when you have a number with an exponent, with a bracket and another exponent, you simply multiply together the two exponents. That is a brief overview of the laws of exponents. Incredibly important you know all of those and have practiced them with good methodology on dozens and dozens of questions. They come up all the time. Okay, next one, the law of square roots. The square root of a square gets rid of the square. I guess most people know that, but I've seen mistakes made on that many times. Just for context, I've tutored maybe 1,500 students. So I'm using that experience to tell you what kind of mistakes people make. A lot of people don't realize that when you square root a number that's squared, you just get the number. Even more people, I would say, don't realize that when you multiply two square roots together, it's the same thing as square rooting the product of those two things. For example, root 3 times root 5 is just root 15. I wouldn't say that comes up that often, not to scare you, but it's a good thing to know. Now, just like we saw with powers up here, that when you have a fraction to a power, the power applies to the top and the bottom. Same thing for square roots. If the square root applies to the entire fraction, that's the same thing as the square root at the top and the square root at the bottom. The same rule there. I would definitely agree that laws of square roots and particularly practice questions about square roots are things that students tend to avoid because they see it as a boring or irrelevant topic. But yes, it does come up quite frequently in the GRE and GMAT. And the exam providers know that students like to avoid that topic, so there's often a question in there on it. So I would encourage you to revise it. Interesting, the laws of even and odd numbers. What I would say about that is often I see students stressing too much about memorizing all of these. I would actually say there's only one law you really need to memorize, and the rest you can just make up on the spot. What am I talking about? Well, when you multiply together two numbers, if there is a single even when you're multiplying, the answer will be even. In other words, if you do an even times an odd, because there was an even in there, the answer will be even. If you do an even times an even, because there was an even in there, it will be even. If you did an odd times an even, because there's an even in there, the answer will be even. To reiterate, if there's a single even in an entire product of integers, the answer will be even. That is a great thing to know. There is a natural follow-up to that, which is the only way to get an odd answer. You might be thinking, how do we end up with an odd if everything with an even in ends up being an even? The only way to end up with an odd when you're doing the product of integers is to have everything be odd, like an odd times an odd times an odd, or an odd times an odd here. That is a cool rule to know. Single even in a product, even answer. And the only way to get an odd, if everything is odd. The thing about adding things up, I honestly don't think you need to memorize that. The reason being, you can just make up examples, right, with even and odd. If you forget that an even plus an odd is an odd, you could just make up two numbers, like 2 plus 1, check it out, turns out it's odd, and therefore the answer is going to be odd. That's the cool thing about even and odds. If it applies to one set of even and odd numbers, it applies to all of them. You don't need to check multiple sets of evens and odds. If you forget what an odd plus an odd is, just make up any. Do 5 plus 5 and it's 10. And then you know for all time that an odd plus an odd must equal an even. You don't really need to memorize the addition rules. Just memorize those two things about products. If there's a single even in the product, the answer is even. And if it's all odds, that's the only way to get an odd answer. That is my opinion on even and odd numbers and the rules you need to know. And I would say most students aren't really fully equipped to deal with odd and even questions because they don't know those rules. What's the next one? Distance, speed, and time formula. I've covered this in another video, so I'm not going to go into depth here. But I'd say the most common mistake here is not to not know the formula, so to speak. Most people do know one of these three formulas. They're all just rearranged versions of the same formula. Let's just say, I think this one is the one most people know, speed equals distance over time. What I don't like about that is that if I asked you, tell me what the time is, you would have to rearrange that formula to say that time equals distance over rate. And often that takes time in the tests, and I don't like that. That's why I prefer a triangle. So if you don't know about the triangle, you can quickly draw it out now. I've done a full video on it. but it's a triangle with D at the top and then S and T at the bottom. So D at the top and then an S times T at the bottom. And the beauty of that triangle is that you can just cover up one of the letters that you're trying to find and the triangle will tell you instantly what to do. So for example, if you want to know the time, you cover up the T and it says D over S, distance divided by speed. Cover up the distance if you want to find the distance and it says speed times time. Cover up the speed if you want to find the speed and it says distance divided by time. So the triangle automatically rearranges the formula rather than just memorizing one of these three formulas and then rearrange it yourself in the test. The triangle gives you all three formulas for the price of one. If that was confusing, please do check out my speed, distance, time video and practice many questions because this definitely will come up, distance, speed and time. Again, I think most people know one of these formulas, but they get stuck in the exam rearranging it and wasting time. Okay, slope of a line. Oh yeah, most people forget this. Most people have a lot of problems with this. The vast majority of students come to me not knowing this formula about y equals mx plus b, and they constantly need to revise the m, the slope, and x-intercept, y-intercept. It's a very commonly misunderstood topic, deserving of a lot of time. It's not that it comes up terribly frequently. By the way, I have done a separate video on the frequency that topics come up in the GRE, so do check it out based on science. I think I called it What Actually Comes Up on the GRE Quant. Great video to check out. So I wouldn't say this topic comes up super frequently, but it is a topic that when it does come up, most students have problems. It's far too complicated to get into just in this video, but essentially this is the equation of any line where m is the slope, x is the x-coordinate, the horizontal coordinate, y is the y-coordinate, the vertical coordinate, and b is where it crosses the y-axis, called the y-intercept. And any line can be expressed using this formula. Scrolling down here, many people also don't know that a completely horizontal line has a slope of 0. In other words, its equation would just be something like y equals 2 or y equals 3. That would just be a horizontal line going through the y-coordinate of 2 or the y-coordinate of 3 respectively. Many people don't know that. Likewise, they don't know an equation like x equals 5 is just a vertical line going through the x-coordinate of 5. But again, there is too much to cover just in this formula review, but I would say this is probably the #1 topic that I see students at the beginner or intermediate level not know how to do. And I think they're probably going to go into a bit more detail here. Yes, so many people don't know the equation of finding the slope, which in its simplified form is the rise over the run. You pick two coordinates on the line, you calculate how far it's risen between the two coordinates and how far the line has gone horizontally, the run between the two coordinates, and you divide the two results. If you want the more mathsy version of that, you get the y coordinates and subtract them. You get the x coordinates of the 2 points and subtract them, and then you divide the answer. That will give you the m. Yes, I have done several videos on coordinate geometry, so if this is a topic that you want to revise, do check them out. Averages, I've covered this a lot. I think you guys know my opinion on averages and what you need to do, as in you multiply the average by the number of terms to find the total. But I would agree that people often forget the definitions of the other averages, not just the mean, which is the one I was talking about, but the mode, being the number that comes up the most frequently, the most common number in a data set. Pretty rare to see mode come up in a test, but it can come up. Much more commonly, the range. Did you know the range is the biggest number in a set? Take away the smallest number in a set. Quite a lot of people forget that. And median. I think most people know that the median is the middle number, but many students forget to put the numbers in order before finding the median. People know kind of that median means middle number, but they often forget to put the numbers in order and then find the middle number. Quick hint, by the way, if there are two middle numbers exactly in the middle, you add them both up and divide by 2 to find the true median. And as for this formula that they've just thrown in there about average speed equaling total distance over total time, I would say that's true, but it's a lot more complicated than that. I did a whole video on average speed. It involves making up a distance and all sorts of shenanigans I urge you to check out. Many people don't know how to work out average speed, and it's not as simple as it looks just using the formula. Either way, averages come up every test, so you do have to know about averages for sure. Probability, of course, everyone's favourite. Many people are scared of probability, but as they've written, probability essentially just comes down to how many ways can we get what we want divided by the total number of possible outcomes. Now, many students are realising, seeing this formula sheet, that actually it looks kind of simple, but the reality is a lot more complicated. They might know this basic formula of probability. It's not really a formula, it's just what probability is, the chance of something happening over the total possible outcomes. I mean, this formula is basically saying that if there's 3 blue beads and 1 red bead, the probability of getting a blue bead is 3 out of 4, because there's 3 blues and 4 beads in total. So it's not really a revolutionary formula in the sense that many of you won't know it. But what you guys do know is that real probability questions are generally harder than this, involving phrases that have the words and or and combinatorics. And that's why I've done multiple separate videos on that. And this is probably the flaw of a formula sheet, right? You'd read this and you go, oh yeah, I know what a basic probability is. I'm fine for this test. And then you get the questions wrong in the test because you haven't actually practiced examples or really rehearsed your methodology. So I'm glad they've got it, but the reality is a lot more complicated than that. And finally, percentages. To find x% of a number, you just x over 100 times n. I mean, that's not really true though, is it? Like in the GRE on the calculator, you're not going to use a fraction over 100, you're going to use the decimal, as I've said here. To find 12% of 50, it's 0.12 times 50, not this over 100 stuff. So I wouldn't really count that as a formula. Likewise, with these two formulas, about n is x% of whatever, it's a complicated way of saying it. The much easier way of thinking about it is not through a formula. 5 is what percent of 13? You divide the two numbers, 5 divided by 13. And the thing that's in the denominator is always the word or phrase after percent of. So 5 is what percent of 13? Notice the number 13 came after the phrase percent of, so 13 must be in the denominator. It's not always that the bigger number is in the denominator, it's the number that comes after the phrase percent of. 12 as a percent of 5 would be 12 divided by 5. That will give you the decimal, and then the 100 here is to remind you to times by 100 if you want to convert the decimal into a percentage. And that's why just memorizing a formula is going to be a bit tricky. It's much more important to practice examples so you know which one to divide by which one than it is just writing down a formula, because you'll easily forget what to actually do just by writing down a formula. What you need to do is dozens and dozens of practice examples. However, what I would say is that these last two formulas here, I think they're the last two in the sheet, yes, are actually really good. I strongly advocate for these formulas in my other videos, which is that anytime they're asking you about percent change, so how much has something increased by a percent or decreased by a percent, these formulas are something that I actually use. In fact, these are the formulas that I'd most endorse memorizing from this entire list. Although I've just actually realized you don't need these two formulas. I only teach this one formula. And you might say, well, why are there two formulas if you just need to know this one formula? This formula will give you the percent increase, right? So you do the final amount, the new amount essentially, minus the original amount, divided by the original amount, and then times the answer by 100. That will give you a percent increase. So if a number's gone from 100 to 125, you can put those numbers into this formula and you'll realize that there's been a 25% increase. But you don't need a different formula for percentage decrease. You put the two numbers into the same original formula. Say the numbers have gone from 100 to 75. So the new final amount is 75 and the original was 100. Put that into the formula and out will pop minus 25. And that minus tells you that it's a percent decrease. you don't need a new formula. The minus will tell you it's gone down by 25%. So there's only one formula you need to memorize. I strongly advocate for this formula. It's called final amount, or I just call it new sometimes. New minus original divided by original times 100, times the whole answer by 100. That will give you both the percent increase as a positive and the percent decrease as a negative. That's a nice way to end because that is a great formula for you to actually know. So to sum up from this formula sheet, you can see that for the most part, it's not about memorizing formulas, it's about practicing methods. And that's what the rest of my Quant playlist is about. However, there are some things you need to memorize, and this list has been helpful in reminding us about some of those things. I hope you like this formula overview. There are other formula overview sheets out there, and I can cover those if you found this helpful at all. As ever, leave a like, leave a comment if you learned something from this video, and see you in the next one.